Welcome to Chibuzor Math Physics. In today's video, I'm going to take you through Regula Falsi method, or what we call the Regula Falsi position method. Whatever you call it, it helps us to find the approximate root of which f of x is equals to 0. So our target is to find the approximate root of which f of x is equals to 0. And to do this, we are going to use a sketch. So our topic today is Regula Falsi method. Yes, so it is Regula Falsi method, and like I said, we use this to find the approximate root of which f of x is equals to 0. And just because of curiosity, let me clarify something. Some people might prefer to use this formula because in this question, in this video, I want to show you how to derive the equation we use in the Regula Falsi method. So we are going to be dealing with derivation of the equation of Regula Falsi method, and the formula for this is given by x naught to be equals to x1 into f of x2 minus x2 into f of x1, and all this is divided by f of x2 minus f of x1. Of course, some people will give you another formula which we call x, the initial position. So xi will be equal to afb, f of b minus b f of a, and all this is divided by f of b minus f of a. So whichever formula you choose to use, you will arrive at the same answer. Of course, x naught represent xi, and we know that fb is simply f of x2 because we have fb and we have a here, which is same thing as f. So this is exactly what we are going to be dealing with, but I prefer using a f of b minus b f of a divided by f of b minus f of a. So let me take you through the derivation on how we arrive at this formula. Stay tuned and enjoy the derivation. So now let us see what we are supposed to do. For us to locate that initial position, let us have a sketch that will show us what we are supposed to do. So let's take a straight line. Let's take a straight line here. Mind my drawing. Let's take a straight line there, and then we connect it y-axis, connect it to y-axis. This is our x, and this position is our f of x. Assuming that we have a curve of this way, our initial position, we have a position here which is b. Usually b is positive while a will be negative. Why? Because remember, the formula says f of b. The formula says f of b minus f of a. So this is the initial position, and this will be our f. straight up to here. Good. So this will be our f of b. Good. If this is our f of b, let's say that this is our a. So it means that also this is our f of a, which is negative. So this is the initial position, and our f of a and f of b, they help us to consider the straight line equation. Remember, like I said earlier, we use this method to find the value of x for which f of x reaches to 0. So let us see the derivation. Consider the straight line equation. Equation of a straight line, we simply have y2 minus y1 divided by, if you look at this position, from f of a up to f of b. So you can sketch it. Let me take a different color. Assuming we are sketching from this position down to f of b. So this position down to f of b is simply help us to take y2 minus y1, and if we take f of a up to the position in x, this point, from this position up to x-axis, this will simply be the position of x. So it is x up to 0, because this position is 0. So we can have y2 minus y1 divided by x2 minus x will be equals to 0 minus f of a divided by x minus a. Okay, so now find the value of x that crosses the point. To find the value of x that crosses the point, we will simply have f of a from this position, f of a minus f of b. F of b is here, f of a from this position up to here, divided by b minus a. This is our b position, and this is our we take b, this is f of b, this is b, and this is a, so b minus a, and this will be equal to negative f of a minus x minus a. Here we simply do cross multiply and do little algebra in manipulating this. If we cross multiply this way, we simply have x minus a into f of b minus f of a. This will be equals to negative b f of a plus f of a plus a f of a. Let's get rid of this so that we have space. So it will be, this is b f of a plus a f of a. Okay, so now if we expand this, we will simply have x f of b minus x f of a. This will also go multiply each other. It will have a f of b plus a f of a, and this will be equals to a f of a minus b f of a, b f of a. If you observe, we have a f of a and we have a f of a, so we can actually cancel. When you have a f of a f of a, we cancel that. So let me get rid of this so that we have space to continue with this derivation. So now if once we cancel these two, we'll be left with x into, can have that f of b minus f of a. This will be equals to negative b f of a plus a f of a plus a f of a. Sorry, so from here what we have is if we open that bracket, we simply have x f of b minus f of a minus a f of b, and this will be equals to negative b f of a. Exactly, this is what we have, and our x initial position will become a f of b minus b f of a, and this will be divided now by f of b minus f of a, and this is our formula that we also call x naught to be equals to x1 into f x of x2 minus x2 f of x1 divided by f of x2 minus f of x1, and this is how we derive the equation, the formula for regular Falsi method. In the next video, we should be dealing with calculation on how to use this formula to evaluate the root of which the approximate value of f of x is equals to 0. See you in our next video, and if you are joining us, hit the subscribe button so that you'll be notified in our subsequent videos. Otherwise, see you. Galagash.